Okay, hello everyone, and welcome to the International Conference on Pattern Recognition Systems. And in this session, section number 7, Natural Language Processing and Recognition. My name is Romina Torres, I'm the chair of this session, and we have our first paper in our first presentation, Multitask Learning Transformer, Comparative Analysis of Emotion Classification and Intensity Prediction in Social Media, of the authors Latif Ladid and Xin Liang, and the presenter will be Kasim Labib.
Thank you. Good day, everyone. My name is Kasrat Labib, and I'm here to present a comparative study on emotion classification and intensity detection in social media. So this is my university project. I'm from Kingston University. So to start the presentation, I would like to give a small thought. So imagine this: you buy something online, you didn't like the product, it's faulty, and you leave a bad review maybe to the Amazon. Now, what happens like when that review goes to the company? It's a one-star review, and there are thousands of them that the company has to filter out and segregate. So, how they can make it more efficient? We propose that we add another layer on top of it where we can identify which review is more angrier, which review has more frustration. And that way they can really say, hey, let's prioritize this and improve the customer satisfaction. So what we are trying to build is a system that can identify emotions and predict their intensities at the same time. And this has a lot of applications, like the one I just said. Other applications can include crisis management, where we can detect extreme fear and respond to relevant authorities accordingly. Event planning and marketing, where we can identify the emotions or what people are talking on the social media regarding an event, and then the marketeers can use those to improve or customize their marketing strategies or even improve customer satisfaction. Or if we talk about educational feedback analysis, this is also related to how we perceive emotions from students and how teachers can use to enhance their educational offering and also improve their curriculum, so they can identify frustration or confusion from students and then tailor their content accordingly. So here is what we are contributing: a multitask transformer model framework that can be utilized by different transformer models. So on top of this framework, we are also comparing this same framework with three different transformer models to set up a benchmark where anyone who is starting up with this kind of approach can take take that as a starting point. So these are the models that we are using, starting with BERT. This is bidirectional encoder representation of transformers, and it is known for its bidirectional contextual representation, which has revolutionized NLP benchmarks. Moving forward, we have Roberta, which is robustly optimized BERT pre-training approach. It uses some better techniques for training and also more data, and hence it also has improved performance on various benchmarks, and that also makes it very suitable for this kind of study involving emotion detection. The last one is a distilled BERT, and as the name suggests, it is a distilled version of BERT with 40% lesser size, but it retains 97% accuracy of the original BERT. So it is very efficient, and it can be utilized in various resource constrained environments. Moving forward, these are some of the key terminologies. So as we have discussed, we are using text-based emotion detection. So I've seen some presentations yesterday, and they were using visual cues and even audio as well. But in case of text, I believe it's much more challenging because you don't have those visual cues, and text can be really, really subjective. So, and we need high accuracy as well, because if you look at the first example of customer satisfaction, if you're not accurate, then it don't have meaning. Secondly, if we come to transfer learning, this is where this is also very important for our study. So a transfer learning allows utilization of a pre-trained model who is already been trained, has knowledge and understanding, and then retrain it for a downstream task. And this is what we are doing with our study as well. And I will explain more on this in the later slides. The next one is multitask learning, and this allows a model to do similar tasks uh, at the same time. And if we, so basically this allows shared representation of different kind of tasks with the same output. So moving forward, I will come to the data set that we are using. This is a public data set. It has, if you look at the bottom, it has suites, emotions, and their intensities. Now, uh, there are four emotions, like four classes: anger, fear, joy, sadness. And in terms of intensities, it has the range is like from 0 to 1. And this is all, especially the intensity part, is manually annotated data. And this is very important because this manual annotation can bring in rater bias. So they have used best will scaling to reduce that. So on the top, we can see the distribution of intensities as well in the whole data set. Moving forward, what we have done is to use this data set is tweet normalization, where we remove the hashtags, duplicate emojis, and also spell correction as well, along with a range of things that are mentioned here. And then we move to the intensity normalization. So I realized that in the data set, there were some outliers where the values are reaching close to 1 or values are less than 0.05. So those are really small values and can be considered as outliers. So what we have done is we have retained only the values that are within 0.95 or 0.05 for consistency. And this is the graph that you can see that is the resultant after the data normalization. Now I will move to our multitask framework. So this represents the whole flow in a vertical manner. First, what we are doing is we are using independent heads. So we take a pre-trained model. It can be BERT, it can be Roberta, it can be Distilbert, and it can be any other one as well, because this is a framework. We add two additional heads on top of it. So we have a regression head, and then we have a classification head. The, the output of each of these heads is calculated independently, and that output is used to calculate the loss, and that loss is then combined together for both of these. And then that is used by the optimizer doing backward propagation to optimize the output of the model in each epoch. So after that, we use the inference using F1 score for classification and R and R2 for regression. So this is a model a bit more wide. So here we can see these are the regression heads in the forward state, and then we do the intensity and emotion prediction. Then we pass it to the loss function, and eventually the combined loss is being passed to AdamW optimizer. So now I will move to the results. So in our approach, as we have three models, we can see that the bird base, that's the top one, gets the highest result in F1, R2, and Pearson correlation R. That means that uh, this is by far the best model if we have to do something like multi-output approach involving these parameters. So now there's a big question, how we benchmark this against other studies. So what we found out that there is no exact comparison with other studies out there who are doing or who are taking the approach that we have. And that's why what we were left with is to use a variant where another study is only predicting intensities, not both of them. So we have to compare the results and set the benchmark, we have to create another variant of our model, which only predicts intensities, just for the sake of comparison. And the output is, so we are comparing against this. This is the VASA 2017 competition. Uh, the top winner of this competition was, if you see here, Peras, and on average, they got 0.747 in regression only task. That is, they predicted with known emotions, only the intensities. So they got this, but our model come on the top and they got 0.779. So this is just for the sake of comparison and for setting up the benchmark. So now I will come to the conclusion. So if anyone needs something that can predict emotion and intensity, the BERT is the best model to do that. There can be other ones as well, depending on how we do the research. But this is just a framework that provides a pluggable transformer-based models, so people can use other models as well. Then one thing that we confirmed and other studies as well, that data normalization, especially if you're using text from social media, the removal of hashtags or mentions or even emojis take little or no impact on the overall performance. Even sometimes it can be negative as well. So that's also what we confirmed. And then we say that our comparative performance against VASA 2017 is quite appreciable in the fact that we got 0.705 versus their 0.747. But R was in the multitask environment while they were doing only intensity prediction. So in the end, I would say that this research, as I've discussed in the start, has various real world applications. So if we can use this model, especially the digital bird, although it has slightly lesser performance, but if we can use that and connect with real world applications like web applications, mobile applications using APIs, so that can really allow applications to uh, do emotion and intensity prediction at the same time. So if we have to see, if anyone is interested in the code, I have a GitHub repo there that has all the code. And thank you.